Hello, everyone. Welcome to our session, Building Next Generation Desktop Appliance with SUSE Enterprise Linux. This is tutorial 1038. And I'm David Duncan. I'm a Partner Solutions Architect with Amazon Web Services. And with me today is Neil Gompa.
Hello. Hi, I'm Neil. I'm a principal consultant at Velocity Limitless. I do lots of stuff in open source spaces. I've been involved in Linux and open source for most of the last 2 decades. And I'm involved in OpenSUSE as well as Fedora and a lot of other places. And I'm here to tell you about the cool stuff you can do with building a desktop appliance in the cloud. And so this is kind of the topic set that we're going to talk about. You can kind of see that we're going to start from introducing about VDI, SLES, and KDE, and we'll move on from there about like why you would choose it, what it does, and what kind of return on your investments you're going to get from this, and of course closing with the future possibilities. So, what is VDI? If you're not familiar with virtual desktop interfaces or virtual desktop infrastructure, it's a technology that allows you to essentially run a desktop not on real hardware. I mean, this feels kind of obvious, hence the virtual part. But, you know, it means that in a very real sense, it means you're abstracting away the things that you would run on physical machines on premises and putting them in infrastructure that can be centralized and scaled out to your own particular needs and requirements. Provides you that flexibility to be able to allocate resources based on your demand and in any location, anywhere. And you also get to add like your own flavor of security to this based on whatever your requirements might be and what workloads you have. So the focus of this presentation is about using VDI, using VDI in Amazon with EC2. Leveraging open source technologies and Amazon-specific technologies, put it together to create a modern work environment that you could take anywhere. So we want to start with talking about SLES and KDE. And the big thing here with choosing KDE for your desktop environment on top of SUSE Linux Enterprise, you get a standardized layout that's very familiar to users. If many users are from the Windows world and they are familiar with that paradigm, KDE Plasma is an excellent desktop environment that provides that look and feel. It includes lots of advanced functionality that you expect from a Unix desktop, like workspaces, task management tools, and it's highly resource efficient. And it provides power user type functionality for people to personalize it and to support their own workflows in a relatively safe fashion, giving people the creature comforts while providing a powerful experience for those who wish to take advantage of it. So, David, do you want to talk about the deployment and integration stuff?
Yeah, I can take this. Obviously, being from the Amazon world, on a regular basis, I'm looking for ways that we maximize that ability for SUSE customers to understand and leverage the EC2 platform. And this just so happened to be one of those great places where as a platform, it is task specific for virtualization, and obviously with SLES being a perfect desktop, especially with KDE there, the combination was just something that we saw as being a perfect fit. And then looking at the opportunity and the option of using some of the additional tools for the virtual desktop interface, we were super excited to look at this because it looked like just an immediately sort of seamless way of creating a desktop deployment with all of the tools that are effective in our toolkits for modern development and transitioning workloads to the cloud. So looking at how that transition looks on AWS, and this could really be any environment that where you have service integrations possible, but this happens to be the one that we've chosen for this presentation. We used Amazon DCV, which is a tool that provides virtual desktop integration through instances on AWS to build out a foundation for high performance remote access. And just looking at the diagram here on the right hand side of the slide, you can see the secrets manager integration here, where we have the Amazon Secrets Manager available for use with this instance, accessed in a private, very restricted, securely restricted virtual private cloud, available alongside all of the tools that you might use to build, say, an event-driven architecture, and then communicate back with that desktop. And from the perspective of the SUSE desktop user, we see this as a foundation for advocating for machine learning integrations, for creating large-scale, for taking advantage of any kind of machine learning technique that can be handled on the EC2 cloud, anywhere where you require flexibility, like training and tuning foundational models for, or anything that requires an inference engine or access to general purpose GPUs or graphical GPUs, including CAD. And we see this Amazon DCV as one of the best tools we have available for remote connectivity, and it's there at no additional cost over the cost of the instance. So it really literally has the ability to save a tremendous amount of dollars and time on annual licensing fees. So these are burstable instances. They don't necessarily need to be stood up for all day, every day. You can set schedules, scheduled times for them to be up and available for use, and that improves your scalability and reduces your security footprint.
So, David talked about what the diagrams and the theoretical architecture and the benefits of doing that. But of course, we got to also talk about how you would implement it. So one really awesome way of doing this is by basically pre-building your images using the Kiwi Image Build tool from the wonderful folks at SUSE. This Kiwi Image Build tool is really built around the idea of building these appliance type things. So from the perspective of Kiwi and what we're talking about, an appliance is merely just a pre-configured system that's just ready to go for a particular purpose. In this case, we want to have a KDE Plasma desktop on top of SUSE Linux Enterprise or OpenSUSE Leap as we can, since they are there, leveraging this to provide a complete experience that you can just hit the ground running on. So the basic workflow for operating this kind of stuff is fairly straightforward. We have a sample that we've built in our Internet Hamster GitHub organization. There's the link to it in the right-hand side of the slide. The main advantage of producing these kinds of appliances is you can use it for creating custom configurations, mass deployments, that sort of thing across education or workforce or CG or any of these other places. It's kind of whatever you want it to be, because you have the power to define what your user experience looks like and what you intend to support and provide through it. So under the hood, you're talking about usually having some structure of declarative definitions, as well as some scripting parts to define what your appliance is going to look like. And as we mentioned earlier, there's lots of these interesting use cases that are built around this idea. You can see here on the right-hand side, we've got a snippet of this Kiwi description. This is actually from the Open SUSE project, which is the upstream for SUSE Linux Enterprise, where they build out these descriptions that you can take and reuse and expand and extend upon. We use this as the basis for the descriptions that I mentioned just a couple moments ago. So you essentially take these descriptions, you add or mix or change up what you need from it, and then you run the Kiwi system build command to then take those and present an image that you can then upload into the cloud. You can then, from that point, take it to testing and validate and make it part of your process, your pipeline for enabling things like regular updates, enhancements of new software and features. You could even do splits, canaries of different types of functionality that you may want to use. It could be very easy to be able to test new vendor software because you could just provision a new variant and then try it out. And if it works, then roll it out. If it doesn't, then throw it away. This is also really advantageous if you want to have common base sets and extend upon it and provide the capability for various individuals and teams to define their own layered experiences on top of this.
I think that's one of the biggest benefits is being able to build that layered experience and then to generate very quickly multiple environments with the very latest versions of the software that you want to test or the software that you want to use.
Right. Like, so, you could combine building these appliances to provide like a common baseline and then use infrastructure tools like Ansible to be able to layer customizations on top of it so that in cases where, right, it might not be significant enough to produce another layered image, but hey, you have these definitions, you have these behaviors and configuration that you need to do. You take the base image, you're as a golden image, and then you produce silver instances leveraging Ansible or Salt or whatever you choose to use for this purpose. You can even use plain shell scripts for all I care. It is totally cool. Well, maybe. I'd worry about your ability to maintain it if you use just plain shell scripts. But
I think there's a lot of cool places here where we can combine these and generally, right, like the best infrastructure deployment tools that I know of are the ones I know the least. The ones I know the most are the ones I'm the most frustrated with.
Well, yeah, the deeper you can do it and all that. But
That's right.
A simple example of something that this infrastructure as code with common tools works is you can use Kiwi to define your golden images, as I mentioned earlier. And then you can use things like Terraform to run up the deployments at scale and then have them kick off Ansible runs to do customizations of the between cloud config user data and Ansible. You can then apply latent configuration that is specific for instances or teams or whatever based on your golden base.
Yeah, which gives you a great sort of policy-based configuration management tool, whereas where state is important, such as in the deployment of the specific instances or the infrastructure in which they're deployed, you can use a tool that makes it a little bit easier to roll that back without leaving anything behind.
Right. And speaking of that, why don't you show us what you've got, David?
Oh, absolutely. So I'm just going to take over the share, and I'm going to go straight to the DCV client. Client itself provides sort of a transfer frame and sort of a simple way of just just providing a window refresh from the instances themselves. In this case, we have one instance set up with the DCV server, and that DCV server has the default user set up for a session access. And I seem to have stepped outside of the frame, but now, so this brings us up to this Firefox window that includes actually our published slide deck, and we can just bring that up and show the same slide presentation that we're showing now. You can see that it's got a very quick response time, quick refresh rates, and it's a great way to get access to a complete modern desktop. So here we have the full KDE desktop, and we're capable of running Firefox here in this case. The console, we can add software. Just recently, we got a, in fact, might have it behind here. Yeah, I recently added Podman to our configuration, so we could run the Podman. We could run our container-based workloads in a simple configuration. Now, that's not the only thing we want to run here. Obviously, we want to be able to, I think this is a great space to be running Minikube or even a deployment of Rancher for configuration management of Kubernetes workloads and some experimentation. But effectively, this is the desktop, and this is what we've got here.
Yeah, so like the idea here is that you have essentially the same experience you would have on a local physical machine,
That's right.
but you have two big advantages in front of you. The first one is this machine can be snapshotted. You could do all kinds of things to do data integrity, protection, system rollback, all those things at the hypervisor level, rather than having to implement them at the operating system level.
So if you look at the instance details here, this is just a standard instance. We happen to be using on the
cloud.
The EC2 platform. Yeah, on the cloud.
The whole point is that this is just a regular machine that you can provision in AWS and then just have at it.
Yeah, and the exciting thing here is, I think, if you look at our inbound rules, the only access to this instance for SSH for the one port that's open is these very specific IP addresses that are associated with our local configurations. So any access has to come from exactly where we are. It can't come from anywhere else. It's not just open to the world. So this configuration provides the opportunity to do some very targeted types of validation on your trust profiles
and your perimeter, right? Because you're creating a very low trust environment where you are essentially implementing a way of doing least privilege by provisioning these machines with targeted security rules and policy control, right? Like people that have these machines, like you can set them up the way whatever you want, including it doesn't matter if they have root access to this machine. It's just for them, and if it falls over, you can just reprovision it, and that can be very powerful.
Right. And so, if we're looking at this, knowing that we're in US West 2 or the Oregon region, I can go back and describe the instance and the configuration of that, of this to show that, well, here we are, we're on a SUSE instance. It's being, its usage operation code identifies it as being an hourly instance. So we know that we're literally paying, or per second, I think this is actually per second billing. that we have a per second billing configuration, and that per second billing configuration means that we were paying for only what we use. So if we make a decision to stop this instance, we're no longer paying for it. We just have this, the storage cost, which is monthly. And so here it is. We named it SUSECon 2025 so that it would be associated with what we're doing today. But yeah, this is all, I'm running this literally from the desktop. This desktop has the ability to make some describe calls and has the ability to interact with infrastructure. So as a developer desktop, it becomes something that's very isolated, but also has the opportunity to be very powerful in terms of your development and your development workloads.
Right. Like the key aspect here is like if you're big into Kubernetes, the biggest thing that this will give you is you don't have to give people very expensive laptops for their work. They can be provisioned inside of your boundary in the cloud with some type of developer workstation environments that then are remoted into, and the DCV software will bridge the local resources with the remote ones, and it can be a very seamless experience to do development or other types of tasks, whatever your security requirements might be.
So here I'm making a call to describe instances on that in this specific region, and then looking down here, you'll see that we have this SUSE instance that we're running right now, named SUSECon 2025, and that has the ability. We're showing the run instances identifier. We're showing that this is a SUSE Linux instance. That we have all this available, and exactly what the specifications are, and we can make some modifications to these. Right, we're not just stuck with this one instance type. We can stop this and change the instance type. That's something that's quite possible for us to do. Anyway,
right.
I'm going to let you go back to the presentation.
So we talked actually quite a lot about what this can do for you while David here was doing the demo. But to kind of reiterate, a big part of this technology is that it gives you the ability to create your own empowered experience customized for your specific requirements. You can do functional testing, you can do development, you can do artwork, CGI, VFX. And again, anytime a change occurs in this environment, you can make sure that that change set is actually recorded, snapshotted, and automated for archival or restoration or whatever. And again, canaries for being able to control deployment and feedback, all this other stuff, right? Combined with, a sophisticated architecture that you can roll out to take advantage of the capabilities of the AWS cloud, with EC2 resources, with metal instances, with GPUs for doing inference and training and model creation, with game development, whatever you want to do here, you can.
Yeah. In fact, you can. And then beyond that, you have the option of, especially with a server like this, the option of having multi-users connected to the same configuration, so you can share like a VS Code environment or different development environments that are collaborative. You have this opportunity to build beta solutions and create feedback loops, closed feedback loops, as they say, back to the development experience, back from the behavioral experience all the way back into the developer experience again. And I think that inference is, everybody is talking about AI now. So obviously, building and training models is a big deal. Ensuring that you have a way to quickly create the vectorization databases that you want to, or apply guardrails or test those guardrails, is super important. And this gives you a way to come back to the same kind of environment.
And
we
you can do it cost effective because you're not buying the GPU hardware, you're time sharing it, basically.
That's right. That's right. I'm using it for exactly the time that I need it, and then after that, I'm shutting it off and moving on. So I'm looking at it in terms of dollars and not in terms of, a capital expense over, amortized over years.
Right. And so we talked a lot about all these different types of development workloads, but I want to highlight a particular one that's kind of important. If you're doing work in a development work on an application workload or such that needs to live on a Kubernetes environment, it can be very, very handy to be able to run a Kubernetes cluster that you have total domain control over. Turns out this is very hard if you don't have enough compute resources to pull it off. But that problem is solved when you have this virtual desktop infrastructure, because you have a desktop environment that feels and acts like a physical machine that can have whatever resourcing you actually need. Again, time shared, so you're only paying for what you use. And you can then run things like have a Rancher desktop running, or do K3s, or even just full-on Rancher with all the features. Or if you need to be able to do nested virtualization, you can use the Metal instances to be able to replicate whatever type of environment you need, and to give you the tools to be an effective developer, tester, whatever you'd like. So like, you get the biggest advantage of all is that you get secure, isolated environments that literally are designed for whatever workload you need.
Yeah, I think that's super important, and especially now that we're experimenting with all of these multi-agentic workloads, large-scale chain of thought. These require a lot more configuration and a lot more services run in the context of their communication and collaborative toolkits.
Yeah, I mean, like, essentially, you take all these things that we just talked about, and you think about, your 18 to 24 to maybe 36-month roadmap of your technology evolution and your IT rollouts.
Yeah,
and you can leverage this stuff to really optimize how you provision resources and support your organization. This can help you move much more quickly in targeted directions, which is really important when you're trying to be cost effective and competitive.
Right.
These days we're all talking about working more with less. This is a way to not have to deal with less. Less is more in this case. Like, you're time sharing what you need, you get to have what you want, and it's reproducible, which is a big deal, especially if maybe you're doing multi-vendor partnerships, maybe you're doing multi-stakeholder engagements, maybe you're doing multi-team things, right? You can do all of this stuff effectively with the combination of SUSE Linux, Amazon DCV, Kubernetes, and KDE. Like, putting all this together, you get a very effective developer workstation environment, or an application testing environment, or any of these other things.
Yeah, or just a user environment. I mean, if this is where you want to see, if you want to see your users come back to a consistent station every time, or you want to make sure that these, you bring in a group of interns and you want them to churn through a lot of content quickly. This is an opportunity for you to stand up that desktop, that $14,000 desktop that you don't want to buy, and not pay for the whole thing, not amortize it over the 3 years that your intern is gone, but to just turn it off and to stop paying for it immediately. So yeah, I think those are great benefits of having this virtual desktop environment, and then having the flexibility to create it in a way that you wouldn't have done before. You might not have realized, or maybe you did. I mean, I think that Kiwi is a very powerful tool, and something that we have to remember is at the core of all of this for you and me is that we've been rolling these images with Kiwi for so long, and looking at how this, how we can affect change inside of the way that virtual machines are deployed and made available, and how ISOs are created, and all of that is an important part of it. And making sure that we have sort of a roadmap that we can apply across multiple deployment environments is a huge deal.
Mm-hmm. Yeah, and you can use this as part of, it seems like a little bit of counterintuitive, but you can use this to gain flexibility while standardizing, because you can standardize on SUSE Linux for a lot of things, and you can very easily qualify all of your workloads and roll them out in a very reliable manner. And so that's, and it's not just, I mean, we're talking about, VDI here and desktops, but everything we've talked about here extends out beyond desktops. You can do this with server workloads, cloud instances, container workloads, like your Rancher clusters can be made in this manner. There's lots of stuff, and you can talk to all the different SUSE teams to, learn more about this, like pairing it up with SUSE Manager, pairing this up with the Rancher Harvester, all these other technologies that are out there. And this is just one really targeted use case that happens to be hugely beneficial. David, do you want to have any words to say to the audience?
I mean, we just scratched the surface in terms of what this looks like, and building out this infrastructure for you to imagine the possibilities was something that was really important to both of us. And taking this to the next level, we hope that we get to see you, in the hallway tracks at SUSECon, and to spend more time with you talking about what your infrastructure looks like and how we can help you envision that, this in your space.
Yeah, I think that'll be awesome. So thank you for watching our presentation. We look forward to seeing you at SUSECon.